Welcome to EDU World Space.
So in this video, we're going to talk about question 18 from chapter 20, which says the electrolysis of aqueous sodium chloride, or brine, is an important industrial process for the production of chlorine and sodium hydroxide. In fact, this process is the second largest consumer of electricity in the United States after the production of aluminum. Write a balanced equation for the electrolysis of aqueous sodium chloride. Hydrogen gas is also produced. So we're trying to write a balanced chemical equation. So before we do, let's write out what our reactants and products are. So we're talking about the electrolysis of aqueous sodium chloride. So one of our reactants is sodium chloride. And then we know that we're producing chlorine and sodium hydroxide. So we have Cl2 and NaOH as our products. And then we're told we also produce hydrogen gas. So we also produce H2. So we have oxygen and hydrogen atoms in our products, but we haven't listed any molecules containing oxygen or hydrogen in our reactants, so that's a problem. But we're told that the sodium chloride is aqueous, meaning it's dissolved in water. So we also have water as a reactant. So that's our source of oxygen and hydrogen. So let's write all this out as a chemical equation. And right now it's not balanced, but we have H2O plus NaCl forms H2 plus Cl2 plus NaOH. And don't forget to label your reactants and products as liquids, gases, or aqueous solutions. So how do we start balancing this? Well, we can see that we have two chlorine atoms on the product side of things in Cl2, but we have only one chlorine atom on the left. So we're going to need a coefficient of 2 in front of our sodium chloride, our NaCl. So now we have two chlorine atoms in our reactants and in our products, but we have two sodium atoms on the left and only one sodium atom on the right. So we're going to need a coefficient of 2 in front of our sodium hydroxide as well. So now we have two sodium atoms in our reactants and two sodium atoms in our products, but we also have two oxygen atoms in our products, but only one oxygen atom in our reactants. So we need a coefficient of 2 in front of our water as well. So now we have two oxygen atoms in our sodium hydroxide and two oxygen atoms in our two waters. So the only thing that we haven't checked on is the number of hydrogen atoms we have. So in 2H2O, we have 4 hydrogen atoms, and on the right-hand side, we have H2 and 2 NaOH, so we also have 4 hydrogen atoms. So this equation is actually balanced.